Okay, this is your basic fraction to decimal to percentage question. They've even done one for you. I don't know why. You guys all know how to solve these. So let's convert 3/20 to a decimal first. And we're just doing a long division of 3 divided by 20. You have to put a 0 point. You can bring a 0 down. 20 ones are 20. 1 0. You can bring another 0 down, and 20 fives are 100. So you get 0.15. What is it as a percentage? You just have to multiply, remember, by 100%, which just means multiplying by 100 to the decimal moves 2 places, you just get 15%. So this one was easy. The next one is going opposite order. Pehle, let's convert from 62.5%, which just means 62. Remember, percent means per 100. So you just have to divide by 100. If you're dividing by 100, the number gets smaller, so the decimal moves to the left, and you get 0.625. And then finally, possibly the trickiest is, how do you convert this to a fraction? So we have 0.625, or even easier, you have, if you get rid of the decimal, you have over 1,000. And now you just have to simplify this, so it's just 625 over 1,000, and simplify any way you know how, but this is your basic sort of. Let's start with dividing by 5. So 5 ones are 5, 1 carry 12, 5 twos are 10, 2 carry, 5 fives are 25, and then niche 5 twos are 10, 0 0. Let's divide by 5 again. 5 twos are 10, 2 carry, 5 fives are 25, and then niche 5 fours are 20, and then 0. And once more with 5, let's do 5 fives are 25, and 5 eights are 40. So after all that working, you get 5 over 8. Great. Okay, more BODMAS. Decimal first. 2.05 plus 1.4, यहाँ पे 0 है, 543. So instead of the bracket, you're getting 3.45 multiplied by 0.2. You can write this as 345 over 100. ऐसे decimal उड़ा रहा हूँ और नीचे 2 zeros. Times, instead of 0.2, decimal उड़ा के नीचे 10. So you get 2 over 10. So just do the numerator first. Forget about the zeros. Those are easy. 35 into 2. Anyway, you know how. If you want, the safest is to write it out like that. 5 twos are 10. 2 fours are 8. Plus 1 is 9. And 2 threes are 6. So it is 690 divided by 1,000. 3 zeros in. So you go. The decimal goes from here to 1, 2, 3. And you get 0.69. So that's the first part. And then the second part is a mixed fraction minus this. First step, let's convert the mixed fraction. Kaise karte the? Let's just do a refresher. All you do is denominator times the whole number plus the numerator. So it's 3 ones are 3 plus 1 is 4. So you get 4 over 3 minus 4 over 5. And now we're back to a simple subtraction. So niche you get 5 into 3, which is 15. I'll write it like this so you know the steps. यहाँ पे 3 है तो when I divide it सिर्फ 5 रह गया, and 5 into 4, so 5 into 4 minus इस side पे 5 है तो 3 रह जाएगा, 3 times 4. So now you get 5 fours are 20 minus 3 fours are 12 divided by 15, which is 8 over 15. Prime factorization of 198. This is LCM wala method. 2 9s are 18, 1 carry, 2 9s are 3 से 33, 3 से 11, 11 से 1. So the prime factors are 2 times 3 times 3 times 11, and that's how you will write your answer. Okay. The next one is tricky. M is 2 squared. Let me just write it like this. 2 times 2 times 3 times 5 times 5, and n is something else where it's even longer, but 2 times 2 times 2 times 3 times 3 because अगर 2 cubed है that means 3 दफ़ा and 3 squared है तो 2 दफ़ा times 7. I'm just writing it because it'll make your steps easier. Find the largest number that divides exactly into m and n. That's just another way of asking what? It's just the HCF. Okay, so what is the largest number that divides exactly into? And the concept is कि it's just like if I had given you दोनों के factors, we want the highest common factor. Remember HCF is highest common factor. So anything that is present in both is a factor. So for example, let's take यहाँ पे एक 2 है, यहाँ पे एक 2 है. So I can write 2. That's fine. And basically imagine getting rid of these. Now what? Another 2 here, another 2 here. So that's fine. Get rid of these. Okay, now, well, there's a 2 here, but there's no 2 here, so that's gone. What about 3? There's a 3 here and a 3 here. That's fine, and I can write it here. What else? 5. Well, this has 5s, this does not have 5. So we're basically done. It's just, if I'd written and I'd done lamba HCF, it would have been the exact same steps, because remember, you can only cancel out a number that divides both, let's say x and y. So we're just looking at the prime factors and finding common prime factors. So 2 times 2 is 4, times 3 is 12. All right, so that's the first one, highest common factor or divisor. And then the next one question is, find the smallest value of k such that mk is a cube number. This has repeated a number of times, so let me repeat the concept. Remember, m was 2 times 2 times 3 times 5 times 5. Okay, for this to be a cube number, each of these factors has to appear 3 times. So you just have to put in the missing factors, that's it. So agar ek 2 missing, I need another 2, so k will need to have a 2. I need 2 more 3s, so k will need 2 more 3s. And then I need, ye do hain, I need 1 more 5, so k will need 1 more 5. And if I simplify this, 2 3s are 6 and 3 5s are 15, and if I do this further, I should get 90. So that's the answer for k. This concept is tricky. It seems tricky, but if they've asked for cubes, you need 3. If they had asked for what if it's a perfect square number, then you just need pairs. So this would be one pair, that's fine. I would need just 1 3, and this is a pair, so I would just need a 3. Okay, this next one is straightforward, so I'm going to do it at full speed. We've been doing prime factors. 60 को 2 से किया 30, 2 से किया 15, and then if you're fast enough, you can just do 5 and 3, because you know that's what it's going to be. So 2 times 5 times 3, that's the answer. Find the smallest integer m such that 60m is a square number. So we know this trick now. We want to add, ye has 60, right? For this to be a square, remember square mein we need pairs of 2. So this is already a pair. This needs another 5, and this needs another 3. So m is just 5 times 3, which is 15. Okay, and then finally the last one, the lowest number that is a multiple of both 60 and integer n is 180. So it's a multiple of both of them. So 60 we already know is 2 times 2 times 5 times 3, that's 60. And then what is 180? Let me just write 180. We know 180 is just 60 times 3, so it's the same, except it also has another 3. Okay, so one more 3. All right, so now what is the lowest number that is a multiple of both 60 and 180? So it's a tricky way of asking that. It has to be, for it to be, and you'll see from the answer, but for it to be a multiple of both 60 and n, right, the common factors hain wo nahi ho sakte, warna you wouldn't need n. So n has to be a number such that, what are the common factors? So 1 2 ye to kat gaye, these are common, this is common so far. Okay, so you're left with 3 times 5 now. So if I cut even this out, now we're left with just 1 3. So we definitely need a 3, but for this to be a multiple, you also need another 3. And why is that? Because sirf agar ek 3 is already a factor here, so it can appear twice, right? So for example, if I said, if the answer for n was just 3, then 3 and 60, the common multiple would just be 60 and not 180. So somehow it has to be a factor that is bigger than 3, I can't multiply by 2 because again 2 is present in 60, so even 6 would be present in 60 and so forth. So I have to introduce a bigger prime factor than 2, and so 3 makes sense, which is 9. Now notice that 9 is not a factor of 60, so somehow it is bigger, and so we would need to introduce another 3 here, which is what we were trying to do. So this was a tricky part, but I think you can work your way through this. So this would be 9. A question on significant figures. These are generally super easy if you remember the concept. It's one point and just 3 sig figs. Start from the left. This is the first, this is the second, this is the number we want to keep, but you just look at the next one. Okay, does it round up or down? The next one is 9, so it rounds up. So you just have 406, but that doesn't mean you get rid, like you just write 406. You still need all of these digits, you just put zeros. So 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, so that's the answer. You've just basically simplified it, got rid of all the other ones, and so you just get this. And the next one is by writing each number correct to one significant figure, estimate the value. So one significant, don't even look at just the first digit. Does it round up or down? Down. So just leave 40. Don't write 4. The mistake, the main concept being tested here is it's not that 41 will ever become 4. It's just that like how precise are we trying to be, and if it's one significant, you just basically put zeros instead of everything else. Okay, so it becomes 40. What about this, right? Like you can clearly see first figure matters, so 9 becomes 10, and then first this does not count, 0 is not significant, but this is significant and it rounds up, so instead of 0.7 we get 0.8. okay, so that's the concept. How do we deal with 0.8? अगर मैं decimal उड़ा दूं, I will get a 10 up here, and notice this 10 will cancel with this 10, so you're just left with 40 divided by 8, which is 5. More fractions, lots of fractions. I'm doing this at normal speed without explaining it. 4 carry 4 into 1 plus 7 carry 7 into 3. Okay, what did I do? Well, actually I'm not going to explain it. We've done enough of these now. 4 plus 7 3s are 21 and 7 4s are 28. You just get 25 over 28. I expect with enough practice all of you guys will have this speed. It's not that I'm trying to demonstrate speed, it's that if when your concepts are clear enough, you know all of the steps and khud hi se wo tez ho jata hai. The next one you can take time because it is converting things into mixed into lowest. Let's just start with this. Remember 1 over 3 is multiply by this and then add that. So 5 3s are 15 plus 1 is 16 over 3. Write the divide as is, and now same concept. 5 1s are 5 plus 3 is 8, so 8 over 5. And now next concept being tested, if you want to convert divide into multiply, I have to flip this fraction, and now I can get to cancellation. 8 1s are 8 2s are 16, nothing else cancelled, but 5 into 2 is easy, it's 10 over 3. But we have to leave it in its mixed number as lowest terms, and that's this. Okay, this is a mixed fraction. Oh, sorry, this is an improper fraction. Let's convert it to mixed. So 3 3s are 9 and remainder रह जाएगा 10 minus 9, which is 1. So 3 whole 1 over 3. Making approximations, estimate this. Under root, you know 35 की जगह 36 because you know that's square roots to 6. What about cube root of 1000? Again, you should become very fast at this. 3 zeros cancel, okay, 1 रह जाएगा, and नीचे I can just leave 0.3. So 36 का square root is 6. 1000 का cube root is 10 over 0.3. We know what to do with decimal. If I get rid of this one space, so I can put a 10 here. So I just have 6 times 10 over 3. Well, 3 1s are, 3 2s are. So I just have 2 and 2 zeros, so 200. This one's very tricky. People might ignore, you won't, but that the units are different. So it's not just about the numbers, it's the units. Let's just convert everything to meters. I think that's the best way to do because we're used to thinking in meters, and also everything is can be converted to that. So maybe starting with, so 500 is meters, so we can leave that as is. 5 centimeters is 1/100th of a meter, so this is 5 over 100 meters. I can write it like that for now. 50 kilometers, each kilometer is 1,000 meters, so this is 50 times 1,000 meters. And then finally millimeters are 1 over 1,000, so 50 over 1,000 meters. So if this was too fast for you, or you don't remember how this sort of works, then highly recommend that you revise units and how to convert. So all I did was centimeter was 1 over 100, millimeter was 1 over 1,000, kilo is always 1,000, and so forth. So I just converted everything to meters. Okay, so just quick revision, but now I don't need to sort these out. If I just cancel and simplify, this is just 5 over 10, this is 5 over 100, and this is 5 times 100. So I don't even have to simplify it further. What's the smallest? It is 5 over 100, so it's this one. The next smallest is 5 divided by 10, so it was this one. The next biggest has to be, well, this is mega big, so this definitely goes here, and what you're left with was this one, 500 meters. Okay, so that's the first part. Then let's do this, main point being the square sign. So remember, anytime you have square, think of a square that each side needs to be converted. So there's a centimeter here, there's a centimeter here, and I want to convert it to millimeter twice. That's the best way to avoid a mistake. So 41.6 is in centimeters. How do I convert centimeter to millimeter? Well, I just multiply by 10, but because it happens twice, I have to do times 10 and then times 10. That's the only trick here. Most people will just do it once, you won't. So anytime you see square, draw a square or know that you have to do it twice. So the first one moves the decimal 1, the next one moves the decimal another, so you get 4160 millimeters squared. This question is a bit tricky. James thinks of a 2-digit number. First of all, only 2 spaces, 2 digits. It is a cube number and it's even. So a couple of hints here, but you have to just guess it. Trial and error would also work. For example, let me just cube 2 and I get 2 2s are 4, 4 2s are 8. So that doesn't work. And the hint here is, if it's even, no odd number can sort of cube into an even number. So somehow we have to start with an even. So it can't be 3. Let's try 4. So 4 into 4 into 4. So 4 4s are 16 and 16 into 4 is 24. 4 1s are 4, 6. So 64. Well, 64 is 2 digits. It's even and it's a cube. So I mean, that's already an answer. And clearly everything else will be bigger because the second you reach 5, you're on 125, 3 digits. So that was the right answer. The next one, Umar thinks of a 2-digit number. It is a factor of 78 and it is a prime number. Interesting. So let's just prime factorize 78, LCM, using prime factors. 2 3s are 6, 1 carry 18, 2 9s are 18. Now what? 3 1s are 3 3s are, and now 13, because 13 is prime. Okay, and now what? So we needed a 2-digit number which was prime and also a factor. It has to be 13. Okay, now write down an irrational number between 1 and 2. So tricky, but if you know your scale, like we need an irrational number, you should know that sort of all of the square roots lie in between, or not all, but like clearly. So square root of 2 is here, as is square root of 3. So either of these would have been correct answers. How do you know this? Well, 1 ka square is 1, but 2 ka square is 4. So somehow the square root has to fall in between these two numbers. So I would write, I don't know, square root, let's do 3. Last question from the first set is one of fractions. A bag contains red counters and blue. Each counter is either odd or even. The table shows each type. So red and odd are 6, red and even, and so forth. Find the fraction of counters that are blue. Interesting. So the first thing before you do anything, If this is a big probability question, I would ask you to add up each individual row and column, but clearly you're going to need total number of counters. So actually, if you have the time, I would just quickly add 6 plus 9 is 15, 5 plus 3 is 8, so this is the total of the rows, and then niche ko 6 plus 5 is 11 and 9 plus 3 is 12. And what you definitely need is this grand total. Either way you do it, you should get 11 plus 12 is 23, and also 15 plus 8 should also be 23, so that checks out. So you have all the totals that you could possibly need. And now let's do our question. The first one is, how many are blue? So blue ka total kya hai? It's 8. Total are 23, so you just get 8 over 23 are blue. What about the ratio of odd to even? So how many are odd? 11. How many are even? 12. So it's just 11 is to 12. When they ask for ratio, I would like you to write it like this. Even though fraction is correct, you won't lose numbers, but I think the technically correct answer is to show it like that as a ratio.